Hello everyone, welcome to Sangam tutorials, SP Gubbi online classes for Ncert and Cbse 10th standard classes. So this is physics light chapter. So after the completion of the theoretical background of mirrors, we are with the numericals on mirrors with 4 formulas. One is the mirror formula, 1 by f is equal to 1 by u plus 1 by v. Second one is the magnification, m is equal to h dash by h. And the relation between magnification and the magnification of concave mirror, that is h dash by h is equal to minus v by u. So with these, keeping these formulas, we are solving numericals. So in the last session we had solved 4 problems on numericals, particularly on concave mirrors. So today we will be going with some more 4 problems on mirror itself, but today I am going to include some problems on convex mirrors also. So this is the onboard. I am having a first problem on convex mirrors, which is very important, because in case of convex mirrors we have only 2 ray diagrams. One is when the object is kept at infinity, the image will be formed at the principal focus, and the second one is the object kept in front of the mirror, somewhere, anywhere in front of the mirror. So when you keep the object anywhere in front of the mirror, the image which is formed is of full size, virtual, diminished and erect. Virtual, erect, diminished. So this is the thing you have to remember here. So based on the first ray diagrams, no problems will be there. If any problem is there on convex mirrors, sure it is on the ray diagram, that is the second ray diagram, when the object is placed anywhere in front of the mirror. So usually, because due to the very important property of these convex mirrors, they have been extensively used in making rear view mirrors, which you have clearly understood in the previous sessions. So I had also used multimedia, some diagrams related to that. So I hope you have enjoyed the last session there. So in today's session, keeping that as the background, those pictures what you have seen in your mind, and using ray diagrams and sign conventions. This is very important. If you are not good with sign conventions, you do not know where to put minus, where to put plus, right, gone, you cannot solve problems on numericals. So before starting the video, I am reminding you once again, if you are not good in that, close the video, go to the sign conventions session what I had done, see it once again, repeat it, practice it, and then come back to this video. If it is not seen or not, if you are very confusing with sign conventions, that is Cartesian sign conventions, I hope you will feel a little bit difficult in understanding these problems, right? I hope you have a grip on that. So based on that assumption, based on that hope, I will go with this problem. Right. A convex mirror used in a bus. So in vehicles usually we use mirrors. So there are 3 types of mirrors: plane mirror, concave mirror, convex mirror. So here, which type of mirror is used in vehicles? So usually in vehicles, rear view mirrors. In the rear view mirrors, usually we use, right, 100% we always use convex mirrors. Why? Because we get a wide view of the field which is behind the vehicle, and the total image or the full image of the object behind the vehicle is seen in the mirror, and it is diminished and virtual and erect. Diminished, virtual and erect, and a wide view of angle can be seen. So this is why the convex mirrors are used in rear view mirrors, right? So based on that, we will be going with this problem. A convex mirror used in a bus has radius of curvature 3.5 meters. So here, for that convex mirror what he has used in the rear view mirror of the bus, it has the radius of curvature 3.5 meters. So it is in meters, you should remember this. Locates a car at 10 meters behind the bus. So if the driver is here, this is the rear view mirror. So he is driving, he looks into the mirror. When he sees the mirror, he sees the image of a small car that is behind the bus. He sees the image of the car from the mirror, that is rear view mirror. The distance of the car from the mirror is 10 meters. From the mirror, the car is 10 meters behind. I don't know to what length is the bus. I do not know the length of the bus here. So let us ignore it. So this is the mirror. Inside the mirror he is going to see the image of the car, which is at 10 meters from the mirror. So that is behind the bus. Okay. Find the position. First point, that is the position you have to find out. Position in the sense where that image is located inside the mirror. Inside the mirror, at what distance? Inside the mirror, at what distance the image of the car is located. That is called the position. Right. Second one is nature. If you want to decide the nature of the image inside a convex mirror, remember this, you have to take the help of the magnification. That is the ratio between the height of the image to the height of the object. So using that relation, magnification relation, you have to find out the nature and size of the image. Writing size of the image is an art. If you understand clearly the position and nature, then you will be able to write the size of the image. It's an art. Right? If you understand clearly, only you can write the size of the image. Okay. Okay. So in order to understand the problem better, we will go with the related ray diagram. So this is the second ray diagram with respect to convex mirrors. So this is a convex mirror. Let us take it. So it is inverted at the inner surface so that it is reflecting at the outer surface. So this is the principal axis, pole of the mirror, center of curvature, and this is the principal focus. Now, here the light rays which are coming in this direction fall on the mirror. Maybe let us imagine that this is the position of the car. This mirror is the rear view mirror of the bus, and let this be the position of the car. So let us indicate it by AB. The distance of the car from the rear view mirror is 10 meters. So this is 10 meters, and radius of curvature of the mirror is 3.5 meters. It is given according to the data it is given. Right. So the light ray which comes and falls on the mirror, it is going to get reflected at this point. It is going to get reflected at this point. But it assumes we feel that the particular ray is starting from the focus of the mirror. Another light ray we are going to direct it towards the center of the curvature, that is towards this we are going to direct that. So this light ray which is directed towards the center of the curvature hits the mirror and it is going to retrace its own path. So here this reflected light ray, it appears as though they meet at this point. So here, if two reflected light rays, that is virtual light rays, meet at a point, we say that the image is formed at this point. This is A dash and this is B dash. So now, if the driver of the bus locates a car at 10 meters behind the bus, so this is the rear mirror of the bus, this is 10 meters behind the bus, this is the position of the car which is at 10 meters. So here, find the position of the car inside the mirror. So inside the mirror, we have to find at what depth the image of the car is formed. So here we have to find this distance, that is PB dash. This distance we have to find out. But we have been given the radius of curvature. So radius of curvature doesn't occur in any one of our formulas. So therefore we have to convert the radius of curvature into focal length. So we'll convert that. So radius of curvature is 3.5 meters. So R is equal to, F is equal to R by 2, that is 3.5 by 2. So that becomes 1.75 meters. So this is the focal length. So now we'll write the data. So first one is object, I'll write it here itself. So object distance is equal to, which is indicated by U, is equal to 10 meters. It is 10 meters. So at this position you have to pause for a second and see the sign convention which is required for this numerical. So object distance is U, but it is measured from the pole of the mirror towards the object in the direction opposite to that of incident light rays. So this incident light ray, this is you are measuring, so therefore it becomes negative. U is equal to minus 10 meters. Now we will take the focal length. So focal length is equal to focal length is equal to f is equal to, that is 1.75 meters. So here most important thing is you are measuring the focal length from point F to P, that is in this direction. So that is from the pole of the mirror to the principal focus, or in this direction. So as you are measuring the focal length from the pole of the mirror along the direction of the incident light rays, therefore this focal length is taken as positive. This is very important. Don't get confused. It is very important. Okay. Next is image distance. Image distance is equal to V is equal to. So this is the image distance, that is PB dash you have to find out. So we should not give any value to V because it is still unknown. So put a question mark and left. Don't put any negative or positive signs for V. Okay. So here we have U, F and V. So the relation between U, F and V is given by the mirrors formula. So let's use it. So by mirror formula, so 1 by F is equal to 1 by U plus 1 by V. So we have to find out V. So therefore we will make 1 by V as the subject. So 1 by F minus plus 1 by U gets transposed, that is minus 1 by U. So 1 by V is equal to 1 by F. 1 by F is 1.75 minus 1 by U. U is minus 10. So as both two negative signs are here, put a bracket there. So 1 by V is equal to 1 by 1.75 is there, it's a decimal, you convert that into a rational number. So point after point we have two decimals, so therefore multiply that by 100 and also divide that by 100. So when you multiply 1.75 by 100, it becomes 175 by 100. Minus into minus is plus 1 by 10. So 1 by V is equal to 1 by 175 by 100. 175 by 100, take reciprocal of that. So 1 by 1 into 100 by 175 plus 1 by 10. So 25 4s are 25, 7s are is 175. Okay, let us go. So 1 by V is equal to 1 into 4 is 4 by 1 into 7 is 7 plus 1 by 10. So 1 by V is equal to 7 and 10 LCM is 70. 4 by 7 into 70 is 4. 7 ones are 7, 10s are 10 into 4 is 40 plus 1 by 10 into 70 is 7. So 1 by V is equal to 47 by 70. So take reciprocals on both sides because we have 1 by V in the LHS but we need V in the LHS. So therefore V is equal to 70 by 47. So V is equal to 47, ones are 47. Approximately it is 1.5. V is 1.5 meters. So what is the position of V? That is, image distance is 1.5 meters. So the image of the car which is in front of the mirror appears to be 1.5 meters inside the mirror. That is at a distance of 1.5 meters inside the mirror. So V is, you can observe here, V is positive. Why V is positive? What we can understand by the value that V is positive. In a ray diagram, while solving problems on ray diagrams with mirrors, if V value is positive, we have told you that if V value is positive 100%, that image will be a virtual image. That image will be a virtual image. If the image is a virtual image, V value will be 100% positive. So it is 1.5 meters now. So this is the position we have found out. Now we have to find out the nature and size of the image. So how to find out nature and size? For this we have to take the help of magnification. So magnification is equal to minus V by U. So M is equal to minus V. V is 1.5, that becomes minus 1.5 by U is 10. U value is, minus 10. U value is minus 10. So M is equal to minus and minus cancels. So 1.5 can be written as 15 by 10 by 10, this 10 by 1. So 1.5 is 15 by 10. This 10 is 10, and by 1 I have written. Take reciprocal. So m is equal to 15 by 10 into 1 by 10. Sorry. Yes. 1 by 10. So that becomes m is equal to 15 by 100. So m is equal to, it is 0.15. 0.15. So as magnification has no units, this can be written as just m is equal to 0.15. So what does it mean? Or else you can do one thing. 5 3s are 15, 5 20s are 30. That is 100. So that is 3 by 20. This can be 3 by 20 also. 3 by 20 is also nothing but 0. That is 15. This is very important, right? Okay. So here, how to say the nature of the image. So here, as the V value is positive, therefore the image what we have got in the mirror is a virtual and an erect image. That is the nature of the image. Now, what is the size of the image? In order to find the size of the image, always we should go with the magnification. So magnification is 0.15. So how to define this? I told you it's an art. Telling the answer is an art. So this is the driver, this is the mirror. He is seeing the mirror here. Car is 10 meters behind. The image of the car is inside the mirror at a distance of, that is 1.5 meters. So the size of the image is, what we have got is 0.15. So the size of the car in the mirror, what he sees is 0.15 times the size of the car. The size of the car, or the size of the image of the car, what he sees in the mirror is 0.15 times the actual size of the car. If the actual size is 1, if the actual size of the car is 1, then the image of the car, what he sees in the mirror is 0.15 times the actual size of the car. So that is the size we have to tell, right? So the size of car is 0.15 times the actual size of car behind the bus. Right? So this is a very important problem. Very important problem, right? So you have to practice this. Very keen observation is required for this. You have to practice well. If you don't practice, you start getting confused in this. So I hope you enjoyed this part, size of the image. If it is 0.13, then the size of the image is 0.13 times the actual size of the car. If it is 0.13 something, so size of the car is, the size of the image inside the mirror is 0.13 times the actual size of the car. So this is the most important statement you have to write. Right? So here V is 1.5 meters, so therefore image is virtual and erect. Image is virtual and erect. Okay, very important. Okay, we'll go with a similar problem on convex mirror, which is very important. Just to get a hold, I am doing a similar problem on convex mirrors once again. Radius of curvature of a convex mirror is 2 meters. 2.0 meters is nothing but 2 meters. So radius of curvature is given. So we do not need that, but we have to convert radius of curvature into focal length using the formula F is equal to R by 2. A truck is coming behind at a distance of 3.5 meters. Just imagine a vehicle. It has a rear view mirror in that. So inside the rear view mirror, from the rear view mirror, a truck is coming behind the automobile at a distance of, that is 3.5 meters. So using this, calculate the position. So by using mirror formula, I have to find out the position you have to tell the nature of the image. So nature of the image is determined by the value of V what we get. So and size of the image is determined by using the magnification formula. Once again I will tell you, you have to calculate the position. The position of the image has to be found out by using the mirror formula. Nature of the image has to be calculated by has to be determined by looking at the value of V what we get and the size of the image, that is by using magnification formula, right? So don't get confused. So this is a convex mirror, so it is silvered at the inner surface. So this is the pole, this is the principal focus, this is the center of curvature. Now radius of curvature of a convex mirror is 2 meters. From here to here the radius of curvature is that is 2 meters. We will convert this into focal length. F is equal to R by 2, that is 2 by 2, that is 1 meter. So radius of curvature is 2 meter, focal length is 1 meter. So from here to here, so whatever you do, that is you have to measure from the pole of the mirror, so that is 1 meter. So we will write the data. Focal length, so write it here, focal length is equal to F is equal to 1 meter. So whether it is positive or negative, that is sign convection. So as you are measuring this distance from the pole of the mirror towards the direction of the light rays, therefore it is positive. Focal length is positive. Now a truck is coming behind at a distance of 3.5 meters from the mirror. So that is, let us locate the truck here. Let us take it as AB. So this is U, that is the object distance. So we write the object distance. Object distance is equal to U is equal to, that is 10 meters, okay, distance of 3.5 meters. So 3.5 meters. So now by sign convection we have to decide whether it is positive or negative. So here by sign convection we see that we are measuring the object distance from the pole of the mirror, that is in this direction, but the light rays are in this direction, therefore U will be 100% negative, right? Next is, you have to calculate the position. So the image will be formed here, approximately somewhere here. The virtual, erect and diminished image is obtained between P and F. So this is A dash, B dash, you have to find out this length. So from here to here you are taking the measurement in this direction, therefore that is the image distance will become positive for you. So image distance is equal to V is equal to how much? So by using mirror formula we will calculate. By mirror formula 1 by F is equal to 1 by U plus 1 by V. So we have to calculate V. So therefore 1 by F minus 1 by U is equal to 1 by V. Okay, 1 by F. F is 1. So 1 by 1 minus 1 by U. 1 by U is minus 3.5. That is minus 3.5, keep it inside brackets, is equal to 1 by V. So 1 by 1 minus into minus is plus 1 by 3.5 is equal to 1 by V. Let us take LCM for 1 at 3.5. So 3.5 becomes the LCM. 1 by 1 into 3.5 is 3.5 plus 1 by 3.5 to 3.5 is 1. So it is equal to 1 by V. 3.5 plus 1 is 4.5. So 4.5 by 3.5 is equal to 1 by V. So let us take reciprocal on both sides. So here 4.5 is there, 3.5 is there. After one decimal place we have, after the point we have one decimal place, after the point one decimal place. Multiply the numerator by 10 and also denominator by 10, so that the value doesn't change. So that becomes 45 by 35 into, that is equal to 1 by V. So let us take reciprocals. So V is equal to that is 35 by 45. So V is equal to, that is we can divide this by 5, 5 7s are 5, 9s are 45. So you should divide 7 by 9. So 9.97s are 63. So we are left with 7 again. Point is there, 9 sevens are 63 again, so it is 0.77. 0.77 can be written as 0.78 on rectification of decimals, that is 0.78. So here the value of V is plus, that is plus 0.78, it is not minus. So therefore, as the V value is positive, as V is positive, therefore image is virtual, and erect. Virtual and erect. So this is the position, that is, as V is positive, image is virtual and erect, that is the nature of the image. So here 0.78 indicates that if this is the rear mirror of the vehicle, so the image is formed 0.78 meters inside the mirror, that is behind the mirror. If you see the mirror like this, so inside the mirror it is 0.78 meters, it is located. So V is that. So we have to calculate the size of the image. So in order to find the size of the image, we take the help of magnification. So M is equal to minus U by U. So M is equal to minus of V value is 0.78, that is 0.78 by U value is, we have it, that is minus 3.5. So M is equal to minus and minus cancels. So 0.78 by 3.5. So when you multiply this by 100 and also this by 100, so we get M is equal to 78 by that is 350, that is 3.5 into 100 is 350. So when we divide, that is 78 by 350, so we get a decimal. Or else you can do one thing, very simple thing. Instead of writing 0.78, you can write this value, that is V, this value, that is M is equal to V is equal to, that is 3.5 by 4.5 itself, that is V value, that is minus 3.5 by 4.5 by U is what we have got is minus 3.5. So minus cancels. So M is equal to 3.5 by 4.5 into, take reciprocal of this, 1 by 3.5. 3.5 cancels. So M is equal to 1 by 4.5. So 1 by 4.5 can be written as 45 by 10. So take reciprocal of this. So M is equal to 10 by 45. So it is 5 2s are 5 9s are. So that is M is equal to 2 by 9. So let us stop it here. M is 2 by 9. So you have to write the statement here. That's very important. So now, by looking at the value, that is M is equal to 2 by 9, we can write something about the size of the image. So the size of the image, what we see inside the mirror, the size of the truck which is coming inside the vehicle, its image is falling inside the mirror here. The size of that image is 2 by 9 times, that is 2 by 9 here, 2 by 9 times the actual size of the truck. The image of the truck formed in the convex mirror is 2 by 9 times the actual size of the truck which is coming behind. So we write the statement, the image is 2 by 9 times the size of 2 by 9 times the size of truck. Okay, send it. Okay, the image of the truck is 2 by, the image of the truck inside the mirror is 2 by 9 times the size of the truck, or actual size of the truck. So this is a very important question. Look at the next problem, very important. An object 5 cm tall is placed in front of a mirror. So imagine a mirror. We do not know what type of mirror is, because mirror is unknown here in this problem. We do not know whether it is a concave mirror or a convex mirror. So therefore I won't draw any ray diagrams. An object 5 cm tall is placed in front of a mirror. So that's the object distance. Object 5 cm tall. Okay, sorry, it is the height of the object. So object height. Object height. So that is always taken as h. So h is always above the principal axis. Therefore, it is always positive. So that is, according to sign convention, it is plus 5 centimeters. Is placed in front of a mirror at 20 centimeters from the mirror. So whatever we measure will be measured from the pole of the mirror. So therefore, whether it's a concave mirror or a convex mirror, the object distance is always negative. So therefore, object distance is equal to, which is indicated by u, is equal to, that is 10 centimeters. So which is negative. Okay. 20 centimeters. So object distance is 20 centimeters. Placed in front of a mirror at 20 centimeters from the mirror. So object distance is minus 20 centimeters. If the virtual image is 10 centimeters tall, so you can see here object height is 5, image height has become 10. So these things happen only in concave mirrors. It cannot happen in convex mirrors, because in a convex mirror the height of the image is less than the height of the object. But in case of a concave mirror, the height of the image will be more and the height of the object will be less. It is enlarged and virtual. Enlarged and virtual in case of a concave mirror. That is the 6th ray diagram. Right? So image height. Image height is equal to h dash is equal to, that is what the virtual image is 10 centimeters tall. That is 10 centimeters. So here, according to sign convention, 10 centimeters is also positive, because it's a virtual image and formed above the principal axis. So it is plus 10 centimeters. So find the focal length. We have to find focal length. So focal length, we do not know whether it is positive or negative. Just we will put f question mark and do it. We will not put any sign for that. Right? So okay. So depending upon the focal length, what we get, we will decide whether the mirror is positive, or that is a concave mirror or a convex mirror. Because in case of concave mirrors, because convex mirrors focal length will be positive. In case of concave mirrors, focal length will be negative. Right? So if focal length what you get here is negative, then the mirror is concave. If the focal length what you get here is positive, then the mirror is convex. Right? Find the focal length. Okay, position of the image and type of mirror. Okay, depending upon focal length we can tell this type of mirror. Position of the image we have to calculate. That is, we have to find the value of v. So image distance is equal to v is equal to question mark. Right. So first we will find out v, then we will find out f. Okay, we will use the formula h dash by h is equal to minus v by u. I hope you remember this relationship. H dash, we want to find out v. So v value will cross multiply this. Minus v into h is equal to h dash into u. So minus v is equal to h dash into u by h. We will transpose this negative sign also. So v is equal to minus of h dash into u by v. Sorry, h. Okay, so v is equal to minus of h dash value, that is 10, into u value, that is minus 20, by h value, that is 5. So v is equal to minus of 5 ones are 5, 2s are 10, 2 into minus 20 is minus 40. Minus 40. So v is equal to minus into minus is plus 40 centimeters. So here v value is 40 centimeters. So the height of the image is 40 centimeter, and we are getting it as positive plus 40, because the image is always above the principal axis. So our answer is correct. So what is the position of the images? The image is the height. What is the focal length? position of the image. So that is, the image is formed at 40 centimeters from the pole of the mirror inside the mirror. Inside the mirror, right? So this is V is positive. And next is the type of mirror. Since we will find out the focal length and then we will decide the type of mirror. So by using mirror formula, 1 by f is equal to 1 by u plus 1 by v. So 1 by f is equal to 1 by u. U value is minus 20 plus 1 by v. V value is 40. 1 by 20, 1 by minus 20 plus 1 by 40. So 1 by f is equal to, so LCM is 40. 1 by minus 20 into 40 is minus 21 are minus 20, minus 2 are. Minus 2 into 1 is minus 2 plus 1 by 40 into 40 is 1. So 1 by f is equal to minus 2 plus 1 is minus 1 by 40. So when you take the reciprocals for this, so f is equal to 40 by minus 1. So we will put minus 1 to the numerator. So f is equal to minus 40 centimeter. So here focal length, as the focal length has become negative, so we can come to a conclusion that usually concave mirrors have negative focal length and convex mirrors have positive focal length. So since focal length is positive, therefore it is a concave mirror. So once again, so V is 40 centimeters, so that is the position of the image inside the mirror, that is the image is formed 40 centimeters from the pole of the mirror. So this is 40, this 40 centimeters indicates that the image is virtual, right? And when you compare with the size of the object is 5 centimeters in height and image is h dash is 10 centimeters, so it is an enlarged image. So it is erect and enlarged, virtual and erect, right? So by mirror formula, when you find out the value of f comes negative. So focal length is negative only in concave mirrors and focal length is positive in convex mirrors. So this is how you have to conclude. Okay, we'll go with the next problem, very important. Where should be an object be placed in front of a concave mirror? So let us take this as a concave mirror. This is silvered at the outer surface. This is the principal axis, that is the pole, center of curvature, and this is principal focus. So where should be an object be placed in front of a concave mirror? So where I have to keep the object, that is between C and F or between F and P or beyond C or infinity, that's the question. Front of a concave mirror of focal length 20 centimeters. So focal length from P to F it is 20 centimeters. So as to obtain a real image 2 times magnified. So if I keep the object here, I should get the 2 times magnified of this image, that is object, that is real. So that if it is 2 centimeters, it should be 4. If it is 10 centimeters, it should be 20, something like that. So let us take this as A dash, B dash. So this length will be V, that is the image distance. And if I keep the object here or somewhere between C and F, this is A dash, B dash. I don't know where to keep. I have to calculate this distance from the pole. So I have to calculate the distance from the pole of the mirror of the object, where to keep the object so that the image of the object it should be 2 times magnified. So where I should keep, I do not know where to keep. So that distance you have to calculate. So here magnification is -2 because the image formed is a real image. So magnification is negative. So m is equal to -2. Then focal length is -20 centimeters because focal length of a concave mirror is always negative. So you have to find out the value of V, that is V is equal to how much? That is image distance, image, right? So, object distance. You have to find the object, where the object has to be placed in front of the mirror. Therefore, you have to find the value of U. So m is equal to minus u by v. This is the formula. So m is minus 2. Minus 2 is equal to minus u by v. Minus minus cancels. So u is equal to 2v. U is equal to 2v. Okay. So let us take this mirror formula. By mirror formula, 1 by f is equal to 1 by u plus 1 by v. So 1 by f is minus 20. We will substitute this is equal to 1 by u. Let it be like that. Plus 1 by, okay, u is 2v. So instead of u, we will substitute 2v and let v remain here. So 1 by minus 1 by 20 is equal to, for 2v and v, LCM is 2v. 1 by 2v into 2v is 1 plus 1 by v into 2v is that is 2. So minus 1 by 20 is equal to 3 by 2v. So we will go with cross multiplication. 2v into minus 1 is minus 2v is equal to 3 into 20. So v is equal to 3 into 20 by 2. That is minus 2. So v is equal to that is 2 1s are 2, minus 10s are, so that is minus 10 into 3 is minus 30 centimeters. So this is the image distance. So where should be the object be placed? That is the question being asked here. So v is minus 30 centimeters you have got. You have to substitute the value here. So u is equal to, that is 2v. So u is equal to 2 into minus 30. So u is equal to minus 60 centimeters. So u is minus 60. So if you want the 2 times magnified image of the object placed in front of the mirror, the object should be placed at a distance of minus 60 centimeters and the image will be formed at a distance of, that is minus 30 centimeters if you want the magnified real image. Okay. So usually here v is minus 30 means that is the image distance and u is minus 60.